Day 339 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 313, super ugly number. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. A super ugly number is a positive integer whose prime factors are in the array primes. Given an integer n and an array of integers prime, return the nth super ugly number. The nth super ugly number is guaranteed to fit in a 32-bit signed integer. All right, y'all, so I can understand how just reading that it can be a little confusing and difficult to understand. So let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have the input n equals 12, prime equals an array of integers 2, 7, 13, and 19. The output is 32. Explanation says this array of integers right here is the sequence of the first 12 super ugly numbers given primes being 2, 7, 13, and 19. So let's go ahead and break this example down a little bit further just so we can make it make sense. So they give us an input n. That means they want us to find the nth super ugly number. A super ugly number is a positive integer whose prime factors in the array primes. So as you can see, they give us this array of integers primes, which is in this case 2, 7, 13, and 19. Now, as you can see in this array of integers that in the explanation, this is all of the numbers all of the numbers up to, or the first 12 numbers, excuse me, because n equals 12. So this is the first 12 integers of numbers that have a prime factor of these numbers right here. So with excluding one, we're always going to include one in our list of our list of ugly numbers because one has no prime factors. So since one doesn't have any prime factors, it doesn't break any rules. So we're always going to include one as the first ugly number. Now every number after one, you can see, is going to be a multiple or have a factor, can be a factor of, or one of these numbers can be a factor of any of these numbers, right? So all of these numbers up until we want the first 12. So all of these numbers are multiples of these numbers right here. So as you can see, 2, we could use this number and multiply it by 1. 2 times 1 could give us 4. Boom, we could use 2 times 2. That'll give us, 2 times 1 will give us 2. Then we could do 2 times 2. That'll give us 4. 7 times 1, that'll give us 7. We could use this 2 times 4, that'll give us 8. Then we could use this 13 times 1, that'll give us 13. We could use this 2 and this 7, 2 times 7, that'll give us 14. Then for 16, we could use this 2 times 8, that'll give us 16. Then for 19, we could do 19 times 1, that'll give us 19. Then 26, we could do 13 times 2, or 2 times 13, that'll give us 26. Then for 28, we could do 7 times 4, we could do 2 times 14 to get 28. Then 32, we could get to 32 by doing 2 times 16. So as you can see, all of these numbers, excluding 1 because 1 has no prime factors, we can get by multiplying one of these numbers by another number, whatever number it is, by x. We can multiply any one of these numbers by x, and that'll give us, we can achieve a product of any of these numbers. So that's how the question works, y'all. We just want to, and then we want to get the first 12. So as you can see, this is the first 12, right? Because we could go further. We could go do 2 times 17 and get 34, but that might be the 13th ugly number. We just want the first 12, and 1 is always going to be included. So as you can see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the first 12 because n equals 12. These are the first 12 ugly numbers that we can create by multiplying any one of these numbers by x, right? And x could be any number as a variable. And we can achieve any one of these numbers excluding 1 because 1 doesn't have any prime factors. So since 32 is the 12th number, then that's why we return 32, excuse me, because we're not returning the array of all of the ugly numbers themselves. We're just returning the nth ugly number. In this case, n is 12. So since 32 is the 12th ugly number, we are going to return 32. Sorry, y'all. So let's go ahead and take a look at example 2, just in case that didn't make any sense. And they might try to throw a trick question our way. Let's take a look. So in example 2, we have n equals 1, primes equals an array of integers 2, 3, and 5. The output is 1. Output is 1 because we want the first ugly number, right? And remember what I said up here, the first ugly number is always going to be 1 because 1 has no prime factor. So it doesn't violate any rules. So we always include 1 in our list of ugly numbers. It's always the first ugly number. And since we want the first ugly number because n equals 1, that will always be 1. Explanation says 1 has no prime factors. Therefore, all of its prime factors are in the array primes 2, 3, and 5. Thus, remember 1 is always going to be the first prime number. The first ugly number, excuse me. So since n equals 1, the first ugly number will be 1. So I hope that makes sense to y'all. Just remember the ugly numbers are all going to be multiples of this. So, of primes. So now that we excluding 1. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not going to be that difficult either. And so let's get started. Now the first thing we need to do is we need to initialize our DP array to store the first n super ugly numbers. And all values are going to start as 1 because 1 is the first super ugly number by definition. So, excuse me, y'all, to do that, we're just going to declare a variable. We could call it DP, set that equal to an array. Open up the parentheses of repeating, :1. Then we're going to say comma, count, colon, up to n. Boom. Now we need to create an array to keep track of the current index for each prime. This determines which element in DP to multiply with the prime. So in order to do that, we're going to say declare a variable, call it index DP. Sorry, y'all. And we can set that equal to an array. Open up the parentheses of repeating, :0. So it's going to be array of repeating zeros, count up to, and this time the count is going to be primes.count. Boom. Now we need to start generating our super ugly numbers from index 1 up to n-1 because remember 1 is always going to be the first ugly number, so we can start generating the rest from after index 1 or from index 1. We don't have to start from index 0 because index 0 will always be 1. So we could say for I n 1 ... less than n, so 1 up to n. We're going to declare a variable, call it min value, and we're going to set that equal to int.max. Boom. Now we need to find the minimum next possible super ugly number. So in order to do that, we come right here, we can say for j in 0 ... less than sign up to primes.count. We're going to open up the bracket, and candidates are going to equal the current DP index times prime. So we're going to find the minimum value. We're going to say min value equals min, open up the parentheses, we're going to say min value, then we're going to say comma, DP, square bracket, index, DP, square bracket, J, come outside both of those square brackets. Then we're going to multiply that by primes square bracket j, just like that. Now we need to set the smallest candidate as the next super ugly number, because remember, this is going to return the smallest value with the min. That's what this min does. And now we need to set the smallest candidate as the next super ugly. So we can come right here and we can say dp square bracket I equals min value, just like that. Now we need to advance all indices in the index dp array whose prime times dp index match the minimum value. This is going to help us to avoid any duplicates and ensure that we progress properly. So we're going to, in order to do that, we'll come underneath this. We're going to say for j in 0 dot dot less than primes dot count. We're going to open up the brackets, and we're going to say if min value equals dp square bracket index dp square bracket j times, times, or actually no, we're going to come outside of these square brackets, then we're going to times, then we're going to say primes square bracket j. Come outside that square bracket, we're going to open up the regular brackets, and we're going to say index dp square bracket j plus equals 1, just like that. And now we need to return the nth super ugly number on the 0 base index, so it will be at n minus 1. So we are just going to come right here, and we are going to say return dp square bracket n minus 1. Now let's see if that works, y'all. That should be all she wrote. Told you it wasn't a lot of code. Let's give it a run. Let's give that a run, y'all. Let's see. Okay, we got an error, cannot find. Oh, DPE. This should be just DP, y'all, not DPE. Sorry about that. Now let's run it. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how this LeetCode stuff can get. Ooh, y'all, look at that. Y'all know I love those numbers. 26 milliseconds beats 100% of users with Swift. Those are some good numbers right there. Those are the numbers I like to see. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. But before we leave, y'all, let me make sure, let y'all get one more look at the code. This is the top half of the code. That's the rest of the code. And yeah, y'all, I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.